Good morning, good afternoon. Welcome to our webinar on why OpenStack is a viable alternative to VMware. I'm Christian Huebner. I am the Director of Services Architecture at Mirantis, and I've been through all phases of compute from bare metal to all the way to full virtualization, partly also containers. With me is Heiko Kraemer. Heiko, please introduce yourself.
Yes, thanks. I'm Heiko Kraemer. I'm principal architect in Mirantis. I'm working for Mirantis now since 7 years around. I started in 2011 with my first OpenStack deployment, and then going through all the different areas. So from the operations to the thin layers, so hosting of Kubernetes and Cloud Foundry, and also deployment and resiliency of workloads, and also migration of them. And that's a very quick summary. All right.
The agenda for today is, first of all, the mindset for VMware and for OpenStack is a little bit different, which is what we want to describe, how this differs and what you should consider about this. Similarities and differences. The next step is how would you actually get onto OpenStack? If you decide to want to do OpenStack, the next step or the next point of thinking is how can I get my users, my workloads onto OpenStack? How can I get my users educated? How can I make sure that we are going to be production ready and so on? Then we'll talk about lifecycle management on OpenStack. And finally, we are describing the actual procedure of getting workloads onto the new platform. Okay, we are going to do this together, the development of the mindset. When I started out, and it's been a long time, but when I started out, everything was bare metal. We had hundreds, thousands of servers. Some of them were doing a lot, some of them were doing a little. We had difficulties or challenges getting workloads managed in a way that we would not have to dedicate a specific server on for each workload. If you have a specific server that does nothing but NTP, the server is going to be largely wasted. Everything is stateful, of course. Basically, there is no way, no possibility of ephemeral entities that you can basically just create and delete as necessary. This is everything is built in a way that requires a large amount of administrative effort to make this happen. The operations.
Sorry to interrupt. Actually, you can imagine. I mean, the base back, right? So let's say in the end of 90s or in the 2000 years, right? You have all your bare metal machines, and what you have to do, well, you have to take care of resiliency, right? Every single bare metal machine has multiple disks in RAID 1, RAID 10, whatever, right? That when one disk fails, well, the system is still running, because typically you cannot just easily recreate your host, right? So this was a major drawback, because everything has to be persistent, including operating system, including configuration files, everything, right? And that was, well, painful. Let's put it that way.
Yeah. So the next step was to say, okay, we'll split the server into many pieces. And I mean, most of you are there, so I'm going to go through this very quickly. The idea was to have multiple resources on one server without each resource interfering with other resources. Initially, VMware was relatively simplistic. I remember the very early days. Nowadays, VMware has a lot of features and functionality that has evolved beyond what the original just let's virtualize some workloads approach was. But we still have, to a degree, the stateful entities that And we have the operators have to put some effort into managing the host nodes themselves. You have your operators, not the users themselves, creating virtual networks, creating volumes in many cases. So there is some operations overhead that needs to be considered. And you will still see resource fragmentation, but not as bad as it was on bare metal. And then we are going to go to cloud. Cloud is a little bit more, we are taking tasks that were traditionally operators' tasks, and we give them to the users. I tell the user, okay, here are 50 virtual CPUs, 500 gigabytes of memory, and here's X amount of disk space, do whatever you want with it. And so a lot of the responsibility goes to the users, but also it becomes more rapid creating and throwing away resources.
And I think that is a very important point, right? So I mean, when you take a look back, and especially also in VMware, also this have changed over the years, of course, because well, the the world is still going on, right? When you are thinking about before you have typically long-running instances, right? So you are maintaining actually a virtual machine. So you're doing updates, you are installing new packages, you are whatever you has to do to maintain the virtual machine, right? So therefore, a very famous capability of VMware is the HA feature. So right, if a node is down, the virtual machine is getting well, actually not migrate, just booting up on a new machine, and that's it, right? So, but now to the mindset shift. In OpenStack, this is actually entirely different. Not only in OpenStack, it's also in all cloud providers, right? How actually the idea of a cloud, of resources. So you're not really maintaining a virtual machine anymore. You're not taking care of it. You're not installing or upgrading packages. You just throw it away and boot the new image up with all the updated versions, right? And do the full automation, configuration, and deployment the rest, right? This is typically, well, how it should look like in OpenStack. So this is the major shift what you have to think about.
So one thing that I would like to add here is you can run OpenStack the same way that you can run in VMware. You can make everything persistent, and you can run long runners the way that you traditionally want to do it. If you have customers internally, or if some of your team members want to run their VMs pretty much the same way as in VMware, then they can do this. And we have instance HA now that is possible to create something very similar to the VMware instance HA, but you are gaining a new capability, this capability of very rapidly, like for instance, we have an operating system that's on ephemeral storage. This gets thrown away if there's a new version of the operating system. This OS image gets thrown away, and a new one gets booted up. And then you attach your persistent data with the persistent volume again. So there is both is possible in OpenStack. You do not have to shift your mindset entirely right now from here to there, but this is a process that goes on over time.
All right, next, I guess. This here is just, again, a very quick summary. Some parts we already have mentioned. The major part, of course, VMware is closed source. OpenStack is open source. VMware is, in nature, a single vendor. And with OpenStack, you have actually the choice, right? Mirantis is not the only vendor. You can have also a couple of others, right? So you can actually freely choose. But underneath, it's running OpenStack. What means that, of course, when you change the vendor, they are doing the things differently. Most likely LCM, right? So the deployment and second day operations. But important is the APIs and the front end in terms of communication with the system, it stays the same. So even if you move to another vendor, you don't have to think about updating of CI pipelines or any libraries what you are already using in your company. That is easily possible.
Right, and this is also the reason why it's not possible for any of the OpenStack vendors that have an OpenStack distribution to simply go and twist the price gauge to the absolute maximum. We have to all be competitive among each other. Otherwise, we cannot do business. So that is the major advantage here, that you have competition and that this keeps the prices and everything reasonable.
Yes. The rest, I think. About persistence, we have already spoken about long and short living instances. So in OpenStack, really, as Christian already mentioned, you have, of course, you can have long running rich machines. That of course is just the approach how you're updating typically is different. You can of course also to have a rich machine fully persistent, including operating systems, also possible, right? But it's again, then you're following just another approach, which is typically not how shall I say. It's possible, but some features would have a bit lax. For instance, when you are balancing and scheduling your system, right? This is typically done because of how actually the cloud should be used, right? So for instance, you want to destroy and fire up new machines, meaning the scheduler is searching for the best place to put them, right? And so that keeps the system balanced. And if you have very long run rich machines only, then of course you can have over time a kind of fragmentation. For this, of course, is a solution, right? But I just want to mention that. Yes, one thing here I want to highlight. The API is in OpenStack. An API in OpenStack is only an abstraction layer. What is behind that, right? So meaning you have tons of different possibilities what you can use. For instance, when you speak with your storage system with Cinder API, it's called an OpenStack. The storage system itself, what's behind that, you can freely choose, right? But the abstraction layer is always the same.
Okay, so the question that we often get asked is there feature parity between VMware and OpenStack? And the answer is yes and no. There is no full feature parity. We have for most VMware capabilities, OpenStack has an analog. You can see some examples here. Basically, you can also see that some of those examples, like in the hypervisor itself, you have choice between different options. There in VMware, you essentially have the VMware ESX server. You can also do KVM now, but this is it's traditionally pretty much everyone uses the most people use a VMware ESX server. You have here. There's some components that I'm at least not aware. I'm sure that there are some options, but they are not core VMware as far as I know, like secret management, which is rather useful when you're doing encryption, and we have load balancer built in instead of using a hardware load balancer. But overall, you can find a way in OpenStack to do pretty much most of the things that you can do in VMware. VMware can do most of the things that OpenStack can do. They are just done in a slightly different way. What do you have? Major benefits, abstraction layer for resources. Your software is going to just see this abstraction layer. Your automation is just going to see this abstraction layer. The configuration for that is behind OpenStack itself. So if I create volume in OpenStack, it's always create a volume through Cinder. And what's behind that Cinder volume is really none of my concern. It is possible to, for instance, in OpenStack Cinder, the volume manager, to have different volume types. But they are also, even what's behind those volume types is not the user's concern. The user just creates a volume and gets a volume. Choice of software vendors, of course, you can have different OpenStack distributions from different vendors. You can have components that are coming from different vendors. This goes not only to software, but also to hardware vendors. You can basically have pretty much anything behind there as long as the hardware vendor provides an OpenStack driver, which pretty much every hardware vendor does these days. You have a high degree of flexibility. This is, you can create very complex constructs in OpenStack as a user. I can, for instance, create a switch, and I can create networks that are connected to that, and I can create, I can basically, as a user, I can do almost anything within the constraints that the administrators have originally given me without having to call anyone. It's fully open source. In OpenStack, it's also possible to look into the upstream OpenStack open source, but we are using most of that. There are a few changes that we are making typically when zero-day exploits are found or something cannot be put into upstream OpenStack yet. So we have, in some cases, we have slight changes from the OpenStack code, but by and large, our OpenStack is OpenStack. What is really our add-on is lifecycle management, monitoring, all these things around OpenStack that make it easier to manage for the customer. We have a very large community of people who are doing open source solutions for OpenStack. We also participate in that. And it is possible to find something for to find solutions for nearly everything that you need to solve. Proven enterprise grade. We have a lot of customers.
So let me quickly interrupt in that again. And that is what I mentioned with abstraction layer, right? So you have a solution, what you want to have, for instance, you need this super fast storage backend and let's say archive kind of storage backend B, both different vendors, typically. And really, typically, even small ones has a driver integration OpenStack, and then you just simply can use it, and that is for every single entity. If it comes to network, if it comes to hardware load balancers, whatever, you can put the F5 or Cisco load balancer, hardware load balancer behind the Neutron API. Neutron is the network abstraction of OpenStack. All this makes this community even possible.
Right, and they all behave very similarly. They have some network solutions have features that others do not have, but by and large, if you're creating networks and all these things through that abstraction layer, then it will behave pretty much the same across different backends, storage backends, and so on. Proven enterprise grade. I would not recommend anyone to put something on a platform that was not in production elsewhere in a large scale. We have customers who have hundreds, thousands of nodes under OpenStack, are using them every day for mission critical for their own, for their enterprise IT, and we can show the stability and the performance that OpenStack can offer to fully in a fully enterprise-ready manner. And the last point goes back to the community and back to the flexibility. For instance, if you wanted to create a third-party solution for OpenStack, it's very, very easy to do because you have insight into what OpenStack does and how it does it. This is not as easy if you have a closed source vendor.
So the MOSK ecosystem, we have, this is of course just abstract, right? This is not everything what is, in MOSK, not everything what we have included in MOSK.
Before maybe we should explain what MOSK is first.
Yes, Mirantis OpenStack on Kubernetes. That maybe we should change. That is correct. So the Mirantis OpenStack runs in Kubernetes actually. Kubernetes helps us to simplify the lifecycle management and day two operations. It solves many issues what we had before. I mean, we are in this business with OpenStack already since a long time, since the beginning, I would say. We faced, of course, many troubles. I think some of you are operators, and I think every one of you, whoever upgraded packages and had to roll back those, know what I'm talking about. It's a pain, and Kubernetes just gives us the freedom and the for many capabilities.
Maybe as an example, imagine that you have a hardware failure and one of your controllers goes down. In a traditional way, you would have to put the to create a new controller, to put the operating system on it, and so on, and then you would have to restore all the functionality of the controller piece by piece. We have done this in the past, so we know how painful this is. With Kubernetes, essentially, the controller just gets, it spins up the new pods for the new services, and then automatically puts them back into the cluster. So there is very little effort involved comparatively. Same goes if you're doing rolling upgrades. You're going to do upgrade one controller, the next controller, and so on, all through Kubernetes. And then that way you avoid having to manually do a lot of the tasks that are taken over by the container abstraction.
Yes. So therefore, this is, of course, just a very small abstract. Also, not everything is directly connected to OpenStack or what end users are seeing, right? End users are not getting in touch with KVM, libvirt, Chemo, or something like that. This is, of course, under control of OpenStack, right? Or customers have no clue about that there is a Calico or Istio in there. I mean, for the Kubernetes part, or OVS or OpenSDN or whatever SDN you're choosing. Of course, they don't know that because they just see an OpenStack API, right? But we want to show what is some parts what is underneath. For instance, IAM, right? The central part of IAM and the OpenStack system is Keystone. Keystone is more a service authorization, right? It's not a full IDP. Therefore, we're using Keycloak as another abstraction layer. You can add your existing Active Directory, LDAP, or whatever you have already, of course, and we can do the mapping or the group and user mapping, and then the key signing is then done through Keystone and Keycloak. And LMA part, so logging, monitoring, and alerting, is also, as again, everything here is open source. I don't want to reiterate this always. So the LMA part, also I think it's the most common tools for LMA today. So with Prometheus and OpenSearch, the success of Elasticsearch, since it became let's say a company, and for storage backend the same. For us in Mirantis, we're using Ceph as a default storage backend, but of course if you have an existing whatever NetApp or something like that, it can be easily integrated.
before we go on, what the user essentially sees are those purple boxes. They see they have compute resources, they see they have storage resources, networking resources, and so on. The user does not actually have to concern themselves with anything that is underneath that, which is what we were talking about with the abstraction layer.
So now the big question is, okay, OpenStack looks good. I have VMware, but how can I get there, right? So the transition path. This is, first of all, when we are starting talking with customers, we try to push them to define capabilities, what they require, right, from the OpenStack system. The problem with that is that when you are, the question comes then, okay, but what is available? So if you share then a list what is available, this leads directly in the issue, because the typical customer wants everything. And everything is, of course, possible, but actually most likely not needed, and more complexity, creates issues, or not issues, but, it's getting harder to maintain, and so on and so forth. So we encourage always to choose and define only the capabilities at the beginning, what you really require. You can easily add later. The system is fully dynamic. You can easily add later everything when you miss something or there's a new requirement. Easy, you can add it. But you should start at the beginning only what you really require. The next step is, of course, planning the new infrastructure. You should plan carefully at the beginning and not just starting and growing, because this definitely leads to issues. Then let's take more a look to your, cash cows, let's say that. So actually your tenants who pay the bills, or the users. You need workloads that wants to test on a new platform. A good thing would be, first, a workload that is large enough that you get good data from, and also smaller workloads just to figure out how the acceptance of the users is. Very important is to start from the beginning. When you do this process, when you decide, okay, I'm going this path, and I'm now have done my job in calculating everything. I have procurement done if needed. I have the planning done. So now it comes to the deployment and onboarding of customers. From the start, we suggest educate your customers. How can you do that? Typically, you can do, of course, a real training, but that doesn't scale well, typically. A good thing is, sounds simple, but it's not often that good done, is create a documentation, create how-tos, create the explanation, is the difference between VMware and OpenStack, to show examples, how you update a CI pipeline. Something like that increases the adoption and the utilization of your new environment much faster. You can also, of course, help your customer if that is possible. It depends always on the size and how much workloads you have on your system. But help your customers to, for instance, update the automations, or help them with the migration. The migration will come later to that. There is a bit more to say because there are, of course, different possibilities to do that. And but overall, what I want to say is the transition path must go hand in hand together with your customers. If you leave your customers behind and expect that, let's say, they're just using it like it is, and they have to go through all the difficulties what they will face, because what is Nova, what is Cinder, what is Neutron, and so on and so forth. They have to read everything, and there is a lot of material out there. The community is really, really big. So to create a comprehensive documentation is very, very, very helpful.
This means a documentation of your environment, not the documentation of OpenStack or on any of the components by themselves. So this basically it needs to be give your users a direct insight into what you are doing. There is documentation about OpenStack and everything out there.
Yep.
So first of all, the entry barrier for OpenStack is relatively low. We typically have a set of controller nodes. We're coming to the hardware later, and you have compute and storage nodes. You do not need expensive storage arrays. You do not need specialized network hardware. That is pretty much anything that is out there on the server market is acceptable for OpenStack. The next thing is managed OpenStack offering. We are offering our customers, and so do other OpenStack vendors, a way to run OpenStack without actually having to know how OpenStack works and without having to hire and train a specific team for OpenStack. So the way that this would work or could work is that initially you book the managed OpenStack offering, and your team will get trained, and we're going to work with us to run your environment until your team can take this over. A reliable support for your new ecosystem. We have 24/7 support, mission-critical support for our customers. We have the SLAs necessary for this, and we have access. We have also an automation to get tickets into our ticketing system from your environment before your operators even see them. There's not, in many cases, there's no need for an operator to open a ticket and put something into that ticket. A lot comes in through our LMA system. This is here built in. LMA is built in logging, monitoring, and alerting. There is also a very flexible system that can alert your people. It can alert our people, and gives both us and you the possibility of managing this. If you only want this in your own environment, if for security reasons or anything, this is also possible to configure. This is all open. Next thing is built-in full lifecycle management. Basically, what is manually built in an OpenStack cluster is a seed node, operating system, and packages installed onto that seed node. And then that seed node builds all the components of the OpenStack cluster from the ground up, from the hardware up, communicates with the board management computers on each of the servers, configures the hardware, installs the operating system, installs the OpenStack, installs Kubernetes, installs the OpenStack components, and everything from the ground up. It's all done by the lifecycle management system. It used to be that OpenStack was a very complex system to deploy and manage, and this has very much gone away by building a lifecycle management system that can take over pretty much all the menial tasks. And finally, reuse existing assets. We have a lot of customers who are actually using servers that have had other functionality before, coming from VMware, coming from bare metal, whatever. If you have something available, then in most cases we can make use of it. This is not something that you have to buy new. Okay, here's an overview of what is needed. To the right is a picture of fairly full-featured OpenStack cloud with SAN and everything, with multiple host aggregates, with multiple availability zones. We'll get to that. So an OpenStack control plane is typically 3 nodes. We have found that up to 500 node cloud, 3 nodes is not a problem. It says 32 cores. This is negotiable. If you have smaller clouds, you can have less. This is made for like 200 or 300 nodes with 32 cores. 128 gigabytes of memory and 1 terabyte SSDs, or ideally NVMEs. And then lifecycle management, you can have VMs, but many customers opt for nodes because the mechanisms for the lifecycle management are built in a way that they are clustered. So you need 3 lifecycle management systems. You can have these can either be virtual machines or physical nodes. They can be very small, comparatively very small nodes, 16 cores, 128 gigabytes, and the 2 terabyte SSD, and 500 gigabyte for operating system. For compute nodes, I would recommend a minimum of 2 compute nodes for a test and demo system, because this will give you the opportunity to demo or test things like live migration or something like that. And if you have a storage cluster, self-storage cluster, you can have an external one, or you can have one combined, converged with the compute nodes. If you build very large clouds, I would recommend especially shoring up the memory in the control plane. But given the fact that 128 gigabyte nowadays is pretty much the smallest that you can have a 2 CPU server configured with, then I would, but having a little bit more memory never hurts. So can a deployment be simplified? Planning should be thorough, complete, discussing everything that you need and want discussed. We have offerings for this. We have ADC and ADA are 2 workshop type offerings that help or where we plan together with you what is necessary for your environment and what the cloud is going to look like. This is
ADA is meaning architectural design assessment, by the way.
Yes, ADC is a architectural design consultancy. This is a slightly smaller offering that is for small clouds and for smaller customers. ADA is typically, if you want to build something very large, and ADA is something that is useful to do this 3-day on-site, and then we provide create comprehensive documentation to build a cloud or to design a cloud and define how it's going to be initially built, how it's going to be scaled out over time, what features are necessary, what features are going to be implemented, how they are going to be implemented, what network subsystem, storage subsystem are going to be used, and so on. If you were to build something that is fully reference architecture, we have reference architecture that we can provide, then it's possible to forego this and say basically we are just building a reference architecture cloud. But in most cases, it would be recommended to have a design assessment. Deployment, on the other hand, can be simplified. It is simplified with our lifecycle management system. Basically, everything gets done through the lifecycle management. We have templates that are pre-built, and they are going to be customized for your environment, and then implemented through our lifecycle management system. So basically, if you have 50 compute nodes, every lifecycle management system is going to go into each compute node, boot it up, install the operating system, and so on and so on. So basically, until the node is fully built into put into the cluster. It used to be that it was very complicated to do this, and this is not the case anymore. Second-day operations, this is also pretty much everything is through the lifecycle management system. Servers do not need to be touched. You are basically telling the lifecycle management to do something to a server, take the server out of the cluster, put the server in, and so on. And so this helps the operator or minimizes operator overhead. The self-service component is very important. In OpenStack, self-service is very much emphasized. You can have users that are managed by the admin team, but normally users are doing creating their own infrastructure the way that they need it. Everything's Kubernetes based in our environment, including the full control plane. Every component of the cluster, which makes it much easier to move cluster components around. If you were, for instance, to experience a control plane bottleneck, you have noticed that performance is a problem. You could, for instance, move the LMA system out of the control plane without taking down the cluster.
All right, I will take that again. I mentioned already at the beginning, we will come back later to that, the migration from VMware to OpenStack. It's distinguished into parts, the user migration and the data migration. The user migration, we already spoke about it a bit. So as I said, very quickly to recap, onboarding, help them to onboard the customers, meaning, documentation, help them with examples, with CI/CD examples. CI/CD is most likely needs to be updated, meaning when you're using Terraform Ansible, of course, it needs to be, slightly updated, right? There is an abstraction layer in Terraform, but as you know, it's the actual implementation is a bit different. So let's focus to the data migration. The data migration is, of course, also an important part because you want to have the data somehow on your new platform. And that most likely is what you're doing or what you want to do, or our customers, what they want to do is to move the virtual machines directly to the new platform, right? So that brings some, let's say, complications with, because the data actually is it's an image, right? It's not different to VMware. Well, VMware have other container format. It's not cookout2, it's VDDK, but on the other hand, that is pretty easy to convert, right? What is a bit more tricky is the driver replacement, right? Because in VMware, you have, of course, VMware tools and VMware drivers. On OpenStack, it's KVM, you need Word.io, right? So this needs to be done. This can be manually done. This can be done via automation or any kind of software, right? And of course, last point is before you shut down your source environment and go live. I'm speaking now with from the workload perspective, and going live on a new target environment. You should test it before, right? If everything works like expected. First, I go in both here a bit deeper in the user migration. I have a part, and the data migration I have a part. The data migration I will describe a bit more because I think it's more interesting than the user migration, because we talked about this here. The non-technical part, as I said, you have to provide different kinds of support, right? I'm not going through all of that again because we mentioned it already 2 times. On the technical part, user authentication, of course, the users want to have or should have the same authentication mechanism. What means should? Your security teams want to have still the full control, of course, right? So you want to use the same IDP backend. So it is, as I already mentioned, if the Active Directory, LDAP, or whatever, you want to stay with that, and we can just adopt that, right? We are not copying, or it should not be that you're copying really the authentication to the target system, right? It's just a mapping what is be done. So the signing of the token will still be done by your IDP, but the validation will be done by the system. Then you can also have different other concepts of security, right? You can, in theory, you can say, okay, I define a domain. A domain is the highest layer. It's like what is comparable in VMware? A data center, maybe. then you have a cluster and your folder, right? So, and when you think about, you can define different concepts of authentication, right? You can define a domain admin, for instance, that rules over all the subsequent tenants or projects, right? Which is, in this case, would be a cluster with folders, and the folders have different users, and only users can do stuff what they want to do. Something like that. So you have a bit more freedom here of different concepts, what you want to, or let's say not what you want, what you may have to solve by your corporate rules or requirements, or maybe even country laws. And then, of course, technical, again, what I mentioned already, provide best practices for Terraform and Ansible. I think it's from my experience, it's that this should not be super complicated. It's really just an example. For instance, Terraform here, that's how you spawn up in your virtual machine in VMware. On the right side here, that's how you spawn up in OpenStack. Boom. It's just an example with a link to the official documentation or something, right? It's really not rocket science. The data migration on the other side, this is a bit more complicated, because you want, of course, not shut down your source environment, not environment or workload, right? Because that means, depending on the size of the data, a long downtime. Best case would be a live migration, but this is super hard to achieve. In the most cases, you want to have warm migration, which is typically fine with all the different with all the different requirements, even if you have very strict SLAs. Because warm migration, the final cutover is typically a couple of seconds, right? So what you have to do is you have to enable the CBT, the change block tracking on VMware side. We are creating then a snapshot out of it, transferring this initial data to the target. On the target, it's a volume, right, where data gets put in. Then automatically replace the drivers and creating a snapshot out of it and putting virtual machine. Why snapshot? Good question. Because you want to test it, right? So the replication is always going, and you want to test the workload on the target, right? And when it's got tested, your workload says, cool, that's good. Then you do the final switch over, meaning the delta transfer from the last replication to now. So you have to shut down the source to the delta transfer, which is just a couple of megabytes typically, and then fire it up on the target, and you're good. So pretty straightforward. Same difference, a call to action. So this is actually a summary. So in general, of course, everyone knows technology and software is ever evolving, right? And that's so and therefore we mention always the mindset shift. Of course, we have today, there's another stage of this mindset shift, which is containers, which is the next form, right? The next step, actually. But in our case today, in our topic today, we are focusing on virtualization, of course, right? VMware and OpenStack. Also, do not underestimate your users. A provider tend to say, my users, I don't want to that they have to do anything, right? They don't know, they are sticking with the current approach, they cannot change. Actually, that's not true. Or, well, of course, for some it is true, but for the majority it's not. And we saw this in the past. This was often a blocker, and that could be a downside. Okay, upgrade your skill set and gain more freedom. We spoke about that, right? To educate your customers and yourself. Get the costly gold chains, meaning license costs are expensive, right? You can over time get rid of it. It's fully open source. You can fully take over it with your team, right? And that's actually a good thing also for long time calculations. Of course, if you want, we will help you with that. And at the end, if you really take a look in how OpenStack works and the mechanisms and the automations, actually, it is not that much different, right? Under the hood, of course, there are some differences, but also from the outside point of view, from users' point of view, yes, there are some difference, but it's not that hard. Like it looks at the first glance because of all the different namings and so on and so forth. We had, let's say, put in a couple of questions here, what we always got asked. Can a user use OpenStack in the same way like VMware? Short answer is no. Long answer, it depends. We spoke about it actually, right? Yes, there is a mindset shift. Yes, it looks from the outside a bit different sometimes, but you can also use it on the same way like VMware, right? It is not needed really to go this path. And also, it really also depends, of course, on the use case, right? If you have complex deployments, it's maybe different. Can we expect the same capabilities? Most likely, yes. Not everything, I would say, is there, but also vice versa, right? So there are definitely differences, right? What is if Mirantis were to raise prices again to Broadcom? I think that is also why some of you are here. Well, then you can just get rid of Mirantis, use it by yourself with your trained and educated operators, or go to another vendor, right? That is not a problem. And again, not even another vendor. You can also just search someone who operates for you. That's also possible because there are also companies that just operate OpenStack, right? We have contracts with vendor XYZ. Can we still use them? Typically, yes. That's what means freedom of choice, right? So the backends, of course, can be used as long as there is a driver. It can directly be used. If there is no driver, then of course it can be written one, right? Everything is possible. No magic actually. Can our customers use the same automation tools to deploy workloads? Yes. Every common deployment, CI, CD, has an adapter for OpenStack and can just directly be used. Can our customers use the same authentication? Can OpenStack provide that all data is persistent like in VMware? Christian mentioned that already. Yes, it is definitely possible. You can put the whole virtual machine, like in VMware, on a volume. It's called then boot from volume, and then everything is persistent. Your operating system, really everything is persistent, right? And that's it. Thank you.
Thank you very much for attending. I hope it was informative, and we are looking forward to exchanging ideas with you if you are interested. Have a good day, and we hope to see you to the next webinar.
Thank you, guys. Have a good day.